Hello, I'm Spider-Man and welcome to this introduction to thermochemistry. Thermochemistry is the study of energy change that occurs during chemical reactions. In order to understand thermochemistry, it is important to first understand the concept of system and its surroundings. A system is the specific part of the universe that we are interested in studying. It can be a single substance, a group of substances, or a reaction mixture. The surroundings are everything else in the universe that is not part of the system. The surroundings can include the container that holds the system, the air in the room, and any other substances that are not part of the system. In this slide, we see an example of a chemical reaction taking place within a beaker. The beaker itself is the container or vessel that holds the reaction mixture, and it is part of the surrounding. The substances that are reacting within the beaker make up the system. As the reaction proceeds, energy is exchanged between the system and the surroundings. In this slide, we are discussing the definition of thermochemistry. Thermochemistry is the study of energy changes that occur during chemical reactions. These energy changes can take the form of heat transfer, which is the movement of thermal energy from one body to another as a result of temperature difference. Heat can either be transferred from the system to the surrounding or from the surrounding to the system. For example, if a chemical reaction releases heat, it will be transferred from the system to the surroundings, causing the temperature of the surroundings to increase. On the contrary, if a chemical reaction absorbs heat, it will be transferred from the surroundings to the system, causing the temperature of the system to increase. In this slide, we are asked to think about an ice pack that is placed on a leg. The first question on the slide asks us to identify the object in this image. The object in this image is an ice pack. The second question on the slide asks us to describe in general terms how the ice pack works. An ice pack works by absorbing heat from the surroundings and using it to melt the ice inside the pack. As the ice melts, it absorbs large amount of heat from the surroundings, causing the temperature of the surroundings to decrease. The third question on this slide asks us to describe the heat transfer between the system and the surroundings in this scenario. In this scenario, the system is the ice pack and the surroundings is everything else in the universe that is not part of the ice pack. As the ice pack absorbs heat from the surroundings, the temperature of the surroundings decreases and the temperature of the ice pack increases. In this case, when the ice pack is put on the leg, the temperature of the leg decreases while the temperature of the ice pack increases. In this slide, we're discussing the various variables that are important in thermochemistry. Q, which is heat or thermal energy, is a measure of the total amount of energy that is transferred between the systems and the surroundings. It is typically measured in units of joules, J. Temperature is a measure of the hotness or coldness of a substance. It is typically measured in degrees Celsius. Enthalpy is a measure of the total internal energy of a system, taking into account the heat exchange with the surroundings. It is typically also measured in joules, like heat or thermal energy is. In this unit, we will be discussing these variables and how they relate to chemical reactions. We will also be exploring how to measure and calculate these variables in order to gain a deeper understanding of the energetics of chemical reactions. In this slide, we're discussing the difference between heat and temperature. Heat is the transfer of energy from a warm object to a cool object as a result of a temperature difference. For example, when you boil water in a pot, heat is transferred from the stove to the water, causing the water to increase in temperature. Heat will also eventually be transferred from water to the surroundings as the water cools down. Temperature, on the other hand, is a measure of the average kinetic energy that the particles in the substance have. It is not dependent on the quantity of the substance. So what's the difference between heat and temperature? Heat is a measure of the energy transfer that occurs as a result of a temperature difference and is dependent on the quantity of the substance. Temperature, on the other hand, is a measure of the average energy of the particles in a substance and is not dependent on the quantity of the substance. Understanding the difference between heat and temperature is important in thermochemistry because they are distinct concepts. In this slide, we are discussing enthalpy, which is a measure of the total internal energy of a system, taking into account the heat and work that have been exchanged with the surroundings. Enthalpy is similar to heat in that it is a measure of the energy transfer that occurs as a result of a temperature difference. However, there is one major difference between heat and enthalpy. Heat is usually in reference to the surroundings, while enthalpy is in reference to the system. Enthalpy can be calculated using the following equation. Delta H equals total heat of products minus total heat of reactants, while delta H means a change in enthalpy. Take a look at this. In this slide, we are discussing exothermic reactions, which are basically chemical reactions that release energy in the form of heat. Exothermic reactions have a negative enthalpy change, which means that the energy released by the chemical reaction is greater than the amount of energy absorbed. This excess energy is transferred from the system to the surroundings, causing the surroundings to get warmer. Enthalpy changes for exothermic reactions and are given by a negative sign. For example, the enthalpy change for the following exothermic reaction is negative 89 kilojoules. This means that the chemical reaction releases 89 kilojoules of energy, which is transferred from the system to the surroundings. Exothermic reactions are important in thermochemistry because they allow us to harness the energy released by chemical reactions for practical purposes, such as generating electricity or heating homes. In this slide, we're continuing our discussion for exothermic reactions. As you can see, the enthalpy change for the reaction is negative because the reaction is an exothermic reaction, which means that it is losing heat. In this slide, we are discussing endothermic reactions, which are chemical reactions that absorb energy in the form of heat. Endothermic reactions have a positive enthalpy change, which means that the energy absorbed by the chemical reaction is greater than the energy released. The excess energy is transferred from the surroundings to the system, causing the surroundings to get cooler. The enthalpy change of a reaction can be written as part of the equation or delta H notation. Delta H notation is when the enthalpy can be written either positive or negative next to the equation. Positive if endothermic and negative if exothermic. When the enthalpy term is written as part of the equation, it will either be added to the product or added to the reactant side of the equation. For endothermic reactions, the enthalpy is added to the reactant side, while in exothermic, it is added to the product side. On this slide, we are comparing exothermic reactions and endothermic reactions graphically. On a graph, exothermic reactions are represented by a downward slope with the reactants on the left side of the graph and the products on the right side of the graph. The enthalpy change for an exothermic reaction is the difference in height between the reactants and the products on the graph. On a graph, endothermic reactions are represented by an upward slope with the reactants on the left side of the graph and the products on the right side of the graph. The enthalpy change for an endothermic reaction is the difference in height between the reactants and the products on the graph. By comparing the graphical representations of exothermic and endothermic reactions, we can gain a better understanding of the energy change that occurs during these reactions. Thank you. That was the end of my presentation.